sine law. For the sine law, we need an angle and its opposite side and one other piece of information. So to picture that, if you have a triangle, what we need to have is some angle measure and its opposite side. As long as we have one other piece of information like this, or this, or this, or this, so any of these four items, we'll be able to solve that triangle. Now, a couple cautions here. Number one, we can only use this with acute triangles at this stage. Later on, you'll learn how to do it with obtuse triangles, but not in the grade 10 curriculum. To illustrate it in another way, what we can do is we can use it when we have a side, the angle between, and the other side. Okay, so when you have the angle between the two sides that you know. We can also use it when we have ASA. So that's when we have an angle, a side, and then an angle. So that works as well. What doesn't work and what we use with caution is when we have an angle, a side, and a third side separate from it in that order. Okay, so this one's called ASS, which is angle, side, side. And side, angle, side works, and this one is side, angle, side. Sorry, this last one here is angle, side, angle, and that one as well works. Okay. So this ASS situation, the reality is you can only solve for an acute angle. So if this angle right here is less than 90 degrees, we can actually use it. Okay, but we won't really deal with that in this class. It's just a fair warning right now. And then in grade 11, you'll see how to use it in more detail. The sine law is basically this. It's A over sine A equals B over sine B equals C over sine C. Or the reciprocal of that, sine A over A, sine B over B, sine C over C. Essentially says the length of any side divided by the sine of its opposite angle is the same for all three pairs. If we are trying to find an angle, I like to use the one where you have the angle on top. So that's right here. So if I'm going to solve for an angle, I typically use this one. And if I want to solve for a side, I use this one. Honestly, it doesn't matter, but I like to make my work as simple as possible, and it will be simpler if you follow that idea. So first, let's learn how to use our calculator. If you have something like this, 3 divided by sine 60 times sine 72, as you see in example 1 on the left there, you need to type that into your calculator, and you should get the answer of A equals 3.3. So you should have approximately 3.3 as an answer. On the right side here, well, actually, let me just note, to be careful here, we might just do this, 3 divided by sine 60, and then hit enter, so we got the answer, and then we multiply that answer by sine 72, so that might get you the answer. Example 2, sine A equals sine 72 over 15 times 12. So what I like to do is take this number, divide it, hit enter, then I'm going to multiply by 12, and then I should get an answer. So what you will get at this point is you should get sine A on the left is equal to, and we're going to round this number right here to 4 decimals. So it's 0.7608. And as we did before, the goal here is to get A by itself. So the only way to undo what sine is doing to A is to do the inverse. So we're going to do sine negative 1, 0.7608. That moves sine to the other side of the equation. If you type that into your calculator, you should get 49.5 degrees. Again, just little notes right here. If you're going to round your answer right here, round to 4 decimal places. Generally, that gives us the accuracy we're looking for when we plug it into a sine, cos, or a tan function. All right, example number 3. Find the length of side B to the nearest tenth. So the way we're going to do this is we're going to, because we're solving for B, which is a side, we're going to use this formula right here. So the B over sine B and A over sine A or C over sine C, okay? So we're going to start with our unknown. We're going to put B over sine, and we're going to put it over. So here's B right here. Remember, it's opposite the capital letter B angle. So we're going to do this and this. So it's sine 55 degrees right there. Equals. And what we want to do is we're not actually going to use all three of these. We only need to use two of them. So the question is, which two do we want to use? So we could use this angle, angle C over side C, or we could use A over sine A. Well, I only want to have one unknown when I'm dealing with an equation like this. So I'm going to choose A over sine A because both A and angle A are known. So we're going to put 12, the measure of the side, over sine of the angle, which is 80. And there we go. We have an equation set up with one unknown. We're trying to solve for B, and B is being divided by sine 55, so we're just going to multiply both sides by sine 55. Okay? And this will cross out with the bottom. And now we have B equals 12.0 divided by sine 80 times sine 55. Type that into your calculator. So as before, take it easy, do it well. So I like to do 12 divided by sine 80, get my answer, and then multiply that by sine 55. And I get B equals 9 point, let's go with 2 decimals here, 9.98, lots of accuracy there. And because this one was in meters, we know the answer is in meters as well. So it's 9.98 meters. Fun fact, a larger angle produces a larger side. So notice that 80 degrees right here is a larger angle than 55. So angle A and side A are larger, and side B is a little smaller. It's only 9.98 meters. Example 4. Let's try another one. So again, we start with putting the unknown on top. So because we're solving for an angle here, we're going to use this formula right here. So my unknown is angle S. So I put sine of S. Okay, don't just put S. We have to take sine of the angle. So here's my angle I'm taking and the side opposite. So we're going to put it over 106 equals. Now we want to find one of the angles in the opposite side that we can use. So we have 47 and 78 here. Or we could use this, which is unknown, and this, which is also unknown. So let's not work with T. Let's work with D. So here we would have sine. Again, you have to put the angle on top because this one has the angle on top. Then this one needs to have an angle on top. So sine of 47 over 78. All right, our setup is ready. We have our one unknown that we're solving for. So away we go. So sine S is being divided by 106. So let's multiply both sides by 106. All right, what that does is this crosses out the 106's. Now we have sine of S equals sine of 47 over 78 times 106. I suggest that at this point you just take the right side and punch that into your calculator. So sine of 47, I have to end bracket that, divided by 78. I get another number, and then I multiply that by 106. And I get, remember, 4 decimals, so 0.9939. And we want to get s by itself, and it has sine happening to it. We're taking the sine of s, so we're going to inverse that and move sine to the other side. So 0.9939. And I'm going to use my, get my calculator to plug in absolute accuracy. So I don't even plug in 4 decimals. I plug in every single decimal it had before. For some of you can take a look at your calculator and see if you can figure out how to do that. And your answer is 83.7 degrees. And there you go. Okay, so this is how you solve with a side. Remember to have the side on top. And this one is how we solve with an angle. One other little note. So if you have angle, side, and an angle, and you'll experience this, you have 40 degrees, let's say right here, and 30 degrees right here. That doesn't make sense. My drawing's really bad or something. So let's make this 95 degrees. Let's make this 30 degrees. I'll make it 40 degrees. I'm thinking too much here, or not thinking enough, one of the two. And we have a side, so angle, side, angle. So let's call this 4 centimeters. And let's say somebody asks you to find side x here. Okay. Here's our little problem this time. We would have x over this, so x over sine 95 equals, and then we'd want this side, angle, over this side, or we would want this angle over this side. And now we have a problem because in none of these pairs do we have both solutions. So we're missing this, and bad news is we can't figure that out in one step. But this is actually really quite easy to figure out, because if you have 2 angles, we know that the 3 angles of the triangle should add up to 180. So we'll do 180 minus 95 minus 40, and 180 minus 95 minus 40 equals 45 degrees. So now we know that this is 45, which means we can solve this problem with 4 over sine 45. Okay? So if you ever get ASA, solve for the third angle first. Okay? You'll notice and recognize this question when you come into a problem with it and you can't seem to figure out how to solve it using sine. Let's do one application problem. A telephone pole is supported by 2 wires on opposite sides. At the top of the pole, the wires form an angle of 60 degrees on the ground. The ends of the wires are 15 meters apart. One wire makes a 45-degree angle with the ground. How long are the wires and how tall is the pole? So let's draw the situation. We have a telephone pole. There are 2 wires on opposite sides. So it goes out like this and like this. And it says that the wires form an angle of 60 degrees at the top. On the ground, the wires are 15 meters apart. So we know this right here is 15.0 meters across. One wire makes an angle of 45 degrees with the ground. How long are the wires and how tall is the pole? All right. Let's think through this. So if I have 2 angles, I know I can figure out this third angle. And so that would be 180 minus 60 minus 45. And 180 minus 60 minus 45 is 75. So this is 75 degrees, which tells me my drawing isn't very accurate. I assume that telephone poles are built at a 90 degree to the ground. And now we want to know how long are the wires and how tall is the pole. So I'm going to make a few drawings here. So one, we have a triangle that looks like this, where we know that this is 45 degrees and we know that this is 90, but we know nothing else about it. We have another triangle on the right side there where we know this is 75 degrees, this is 90, but we have no side. And the third triangle that we actually should be able to see is the one that's the outside sides. So it's 60, 45, 75, and here we got 15.0 meters. So this is actually the only triangle we can solve because it's the only one where we have a side length. So we have this, an angle on its opposite side, and we're trying to find x and we're trying to find y here, the lengths of the wires. I'm just going to label them on all the triangles. So we're trying to find x or y on any of these diagrams, and once we get one of them, we have the rest of them. So let's solve it using this bottom one. I'm going to solve for x first just because I feel like it. So remember, we start with the unknown, x over sine of the angle. So x over sine 75 equals 15 over sine 60. So we took the other two pairs. As before, to get x by itself, we multiply by sine 75. Okay, these cross out. Now we have x equals 15 over sine 60 times sine 75. We're going to type that into our calculators. So 15 divided by sine 60. And you get 16.7. So we know that this length right here is 16.7 meters. Similarly, we can solve for y. So let's use this right there. So y, start with your unknown, y over sine 45, awfully thick marker I'm using there, is equal to, and we'll set it to the other known side, or corresponding angle inside. So that's 15 over sine 60. Again, to get y by itself, we multiply by sine 45. This crosses out. We're left with y equals 15 over sine 60 times sine 45. Punch that into your calculator. And you get 12.25. Let's go with. Let's round it down. 12.2. There we go. So now we know this length is 12.2. So the question here was, how long are the wires? We've got both wires. And now we want to know how tall is that pole. So let's call this H right here. H, all those are H's here. Okay. So we have 16.7, we have 12.2, all the way along. So I can't solve for H in this diagram because it's not really labeled there, but I can solve for H in these diagrams. So now that I have that information, so this is the first thing we did. Here's the second. I'm going to go back up here for step number 3. Let's just use this triangle right here. Okay. So if I take a look at this, I have an angle measure. I have a right triangle, so I can use SOHCAHTOA. Okay. So SOHCAHTOA. You could use Sine Law, by the way. It will work just fine as well. What we're trying to find is H. That's our unknown side, and we have this side, the hypotenuse. So we have an opposite and hypotenuse that we're trying to find, so it's sine. So we do sine of, let's call it A, equals opposite over hypotenuse. And we fill in what we know. So A is 75 degrees here. Opposite side is H, and the hypotenuse is 12.2. To get H by itself, we're going to multiply by 12.2 on both sides. This crosses out, and now we just have 12.2 times sine 75. And that equals 11.8. So h equals 11.8 meters. So we have the height of the pole, and we have the length of the two wires right there. And there you go. So sometimes we can use sine law, and then afterwards, once we divide it into right triangles, we can use SOHCAHTOA. So this is how you use sine law to solve triangles.